Hello everyone, Mr. Hissner here, and today we are going to be looking at angle addition, and this is the angle addition postulate. Before this we looked at angles properties and how to use those properties in very similar to what we did with points and lines. So we learned just definitions and different properties of them, and now we're going to look at that same progression from properties of these things to now incorporating numerical values, and as well as algebra and solving for these unknown measures. So that's what we're going to be looking at today. So the angle addition postulate, just like segment addition, really. I mean, it is has a very similar contrast to our segment addition, in so that segment addition, you'll remember that if we had A, B, and C, that we would say that AB plus BC is equal to the whole thing, AC. And here we see something very, very similar. What we have here is different angles. So what I'm going to do is kind of zoom in on these and then color code them. So I'm going to make this one green, how about this one pink, and then I'm going to make the whole thing blue, like on the outside. Okay. And that way we can kind of see what we're going to be adding, what measures. So our angle addition, we will say that we can add the two on the inside. So we're going to add the measure of angle ABD plus the measure of the pink one, which is the measure of angle DBC. And that is going to be equal to, it's going to be equal to the measure of the blue one, the measure of angle ABC. And just remember, just a note that all of our angles have to have our vertex in the middle. This is the vertex of the angle, and we need that to be in the middle of our three letters, so our 3 points. Another thing to note is that this is the measure. That's the measure of the angle. The angle would just be A, B, D. So two different things. When we're talking about measures, we're talking about numbers, we're talking about addition, we're talking about algebra, right? Figures, angles are just figures otherwise, and they are just things. So they have different properties. And this says our question here is use the diagram below to answer question 1 and 2. Really, I'm just going to look at question number 1. And what do we see here? We have, okay, ABD, that's our one in green, that's this one. We're told that this is 48 degrees. And DBC is 78, and we want to find the whole thing in blue here. So we're going to take 48 plus 78 is going to be equal to the whole thing, right? So 48 plus 78 is 126 degrees. Ta-da! So just taking the parts of the thing and then adding them together, So we're just adding the parts together. So angle addition postulate, and this is what we're working with here. Okay, so let's look at what happens when we incorporate algebra. Okay, so we're told that angle PQR, okay, so this looks like it's going to be the whole thing. PQR is 141, and inside, I'll just keep it consistent, inside is 13x plus 4, and then also inside is 10x minus 1. So let's see what we can do. We want to take the measure of angle PQS plus the measure of angle SQR, and it's going to be equal to the whole thing. It's going to be equal to the measure of angle PQR. So hopefully this color coding will help to try and so you can see the angles that we're referencing. So here PQS is 13x plus 4, and we're going to add it to 10x minus 1, and it's going to be equal to the whole thing, which we were told up here was 141. This was 141 up here. And then we're going to do some algebra. So let's combine some like terms. Okay, here they are. There's some like terms, and there's some more like terms. So 13x's plus 10x's, this is 23x's. Plus 4 minus 1, that's plus 3, and that's going to be equal to 141. So now this is just a one-step equation. Or two-step equation. We're going to subtract 3 from both sides. So those 3 cancel. And we have 23x is equal to 138. And since we all know our 23 times tables so well, we know that x is going to be 6. However, if you don't know your 23 times tables, of course you can divide both sides by 23, right? Because these two will cancel, and we find x is equal to 6. But notice we have some other questions. We want to know what's the measure of angle QPS, so our measure in green, and also our measure in pink here. So green was 13x minus 4, so that's going to be 13 times our number plus 4. And then pink here was 10 times our number minus 1. So we have our green angle and we have our pink angle. And what are we going to do? Well, we're going to drop that 6 right in there. So 13 times 6 plus 4, this is 82. This one is 10 times 6 minus 1, this is 59. So this is 82 degrees, and this is 59 degrees. So what did we do here? Well, very similar to our segment addition problems. What we did was we needed to identify what are the parts. So our parts here, green part plus pink part is blue part, right? So I just wrote that up here. Green part plus pink part is blue part. Now, what value was this? Well, this was 13x plus 4. What value was this? Well, it's 10x minus 1. And then the blue value, the whole thing, we were actually given as 141. And then it would just combine like terms, balance the equation, and then divide by the coefficient on x. So divide by 23. We were asked to get the measure of these angles. So we have to use our value for 6, plug it back in, find those values, and then we are finished. Yep, I think that's all. Yep, we are finished. So we will have classworks very similar to this that you will be asked to complete and answer the following questions to. Thanks for watching.